Question 1. Analysis of a financial services organization's cloud architecture strategy for ensuring business continuity and data resilience in Oracle Cloud Infrastructure, OSI, given stringent regulatory requirements for data residency and minimal downtime. The organization's primary OCI region is experiencing an unforeseen, prolonged outage due to a catastrophic regional event. The architect must ensure that critical financial transaction data remains accessible and that the business can resume operations within a defined recovery time, objective RTO, of 4 hours and a recovery point objective RPO of 1 hour. The solution must also comply with data residency laws that mandate financial data to be stored within specific geographic boundaries. Option A. Rely on the existing backups of critical databases and application data, which are stored in object storage within the same OCI region, and initiate a manual restore process once the primary region is operational again. Option B. Implement a cross-region disaster recovery solution by replicating critical databases using Oracle Data Guard to a secondary OCI region located in a different geographic jurisdiction that adheres to data residency requirements, and configure object storage replication for other critical assets. Option C. Deploy a multi-region active-active architecture for all critical financial services, ensuring data is synchronized in real time across multiple OCI regions, and assume that this inherently satisfies disaster recovery needs. Option D. Utilize multiple availability domains within the primary OCI region to host redundant instances of critical applications and databases, assuming this provides sufficient protection against a complete regional outage. Correct answer is B. Implement a cross-region disaster recovery solution by replicating critical databases using Oracle Data Guard to a secondary OCI region located in a different geographic jurisdiction that adheres to data residency requirements, and configure object storage replication for other critical assets. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture, balancing the need for high availability and disaster recovery with cost optimization and adherence to specific regulatory compliance requirements. The organization operates within a regulated industry, implying that data residency, security, and availability are not merely technical considerations, but also legal and compliance mandates. The challenge lies in designing a solution that meets stringent recovery time objectives, RTO, and recovery point objectives, RPO, without incurring prohibitive costs, all while ensuring compliance with the relevant Oracle Cloud Infrastructure, OSI Service Level Agreements, SLAs, and any applicable industry-specific regulations that OCI services must support. The architect must consider the implications of different OCI regions, availability domains, and disaster recovery strategies on both technical feasibility and regulatory adherence. Correct approach analysis. The correct approach involves leveraging OCI's cross-region disaster recovery capabilities, specifically by replicating critical data and resources to a secondary OCI region. This strategy directly addresses the RTO and RPO requirements by ensuring that a failover can occur to a geographically distinct location in the event of a regional outage. OCI's disaster recovery services, such as Oracle Cloud Infrastructure Data Guard for databases and object storage replication, are designed to facilitate this. By choosing a secondary region that aligns with data residency requirements and offers appropriate network connectivity and latency, the architect ensures both compliance and operational resilience. This approach is best professional practice because it is a well-established and robust method for achieving high availability and disaster recovery in cloud environments, directly supported by OCI's features and SLAs. It provides a clear path to meeting RTO/RPO targets while maintaining data integrity and availability. Incorrect approach is analysis. One incorrect approach would be to rely solely on backups stored within the same OCI region. While backups are crucial for data recovery from corruption or accidental deletion, they do not provide sufficient protection against a complete regional outage. If the primary region becomes unavailable, the backup stored there would also be inaccessible, failing to meet the RTO/RPO for disaster recovery. This represents a significant regulatory and ethical failure, as it exposes the organization to unacceptable data loss and extended downtime, potentially violating industry regulations that mandate business continuity. Another incorrect approach would be to implement a multi-region active-active deployment without a clear failover strategy or considering the complexity and cost implications. While active-active can offer high availability, it is often significantly more complex and expensive to manage, especially for disaster recovery scenarios where the primary goal is to recover from a catastrophic event. Without careful design, it might not effectively meet RTO/RPO for a disaster scenario and could lead to data synchronization issues, which could have regulatory implications if data consistency is compromised. A third incorrect approach would be to only consider availability domains within a single region for disaster recovery. While availability domains provide high availability within a region by protecting against localized hardware failures or power outages, they do not protect against a complete regional disaster, e.g., natural disaster, major network failure affecting the entire region. Relying solely on availability domains for disaster recovery would fail to meet the requirements for resilience against catastrophic events, leading to potential regulatory noncompliance and significant business impact. Professional reasoning. Professionals should approach disaster recovery and high availability design by first clearly defining the RTO and RPO requirements based on business needs and regulatory mandates. This involves understanding the criticality of different applications and data sets. Next, they should evaluate OCI's native services and features that directly support these requirements, such as cross-region replication, data protection services, and infrastructure resilience options. A thorough risk assessment should be conducted to identify potential failure scenarios and their impact. The chosen solution should be cost-effective, operationally manageable, and demonstrably compliant with all relevant regulations. Regular testing and validation of the disaster recovery plan are essential to ensure its effectiveness and to adapt to evolving business needs and OCI service updates. Question 2. Process analysis reveals that a financial services application deployed on Oracle Cloud Infrastructure, OCI, requires secure storage for sensitive customer transaction data. The development team needs to access this data for processing, and the application's compute instances must be able to write new transaction records. The organization operates under strict U.S. federal regulations concerning financial data privacy and security. As the OCI Architect Associate, you must design a solution that ensures data confidentiality, integrity, and availability while adhering to the principle of least privilege. Which of the following approaches best meets these requirements? Option A. Configure OCI Identity and Access Management, EAM, policies to grant specific, granular permissions to the compute instances and authorized users, allowing them only the necessary read and write access to the object storage buckets containing the transaction data. Option B. Grant broad allow policies to all compute instances within the Virtual Cloud Network, VCN, for object storage access to simplify management. Option C. Rely solely on OCI Network Security Groups, NSG, to restrict access to the object storage, allowing inbound traffic from the application subnet. Option D. Disable encryption for the object storage buckets to improve data retrieval performance for the application. The correct answer is A. Configure OCI Identity and Access Management, EAM, policies to grant specific, granular permissions to the compute instances and authorized users, allowing them only the necessary read and write access to the object storage buckets containing the transaction data. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture, balancing the need for robust security and compliance with the operational demands of a rapidly evolving application. The organization is operating within the strict regulatory framework of the United States, specifically concerning data privacy and security, as mandated by relevant U.S. federal laws and industry best practices. The challenge lies in ensuring that the chosen Oracle Cloud Infrastructure, OCI services, and their configurations meet these stringent requirements without hindering the development team's agility. Misinterpreting or overlooking specific compliance mandates can lead to significant legal repercussions, financial penalties, and reputational damage. The architect must demonstrate a deep understanding of OCI's security features and how they map to U.S. regulatory obligations. Correct approach analysis. The correct approach involves leveraging OCI's Identity and Access Management, EAM, policies to enforce the principle of least privilege. This means granting users and services only the permissions absolutely necessary to perform their intended functions. Specifically, using OCI IAM to define granular access controls for the object storage buckets, ensuring that only authorized compute instances and users can read, write, or delete data, directly addresses the security and compliance requirements. This aligns with U.S. regulatory principles that emphasize data protection and access control to prevent unauthorized disclosure or modification of sensitive information. By configuring IAM policies to restrict access to specific OCI resources based on roles and responsibilities, the architect ensures that data is protected according to established U.S. legal and ethical standards for data handling. This proactive security measure is a cornerstone of responsible cloud architecture and demonstrates adherence to compliance frameworks. Incorrect approach is analysis. One incorrect approach is to rely solely on network security groups, NSG, to protect the object storage. While NSGs are crucial for network-level access control, they do not provide the granular, identity-based authorization required for data access within OCI. A misconfigured NSG could inadvertently allow broader access than intended, and it doesn't address the authorization of authenticated users or services to perform specific actions on the data itself. This failure to implement proper identity-based access control is a significant regulatory and ethical lapse, as it leaves data vulnerable to unauthorized internal or external access, violating principles of data integrity and confidentiality mandated by U.S. regulations. Another incorrect approach is to grant broad, allow policies to all compute instances within the VCN for object storage access. This violates the principle of least privilege and creates a significant security risk. If any compute instance is compromised, all data in the object storage could be exposed or manipulated. This broad access is a direct contravention of U.S. data protection laws that require organizations to implement reasonable security measures to protect sensitive data. Ethically, it demonstrates a lack of due diligence in safeguarding customer or proprietary information. A further incorrect approach is to disable all encryption for the object storage to improve performance. While performance is a consideration, disabling encryption for data at rest is a critical security and compliance failure. Many U.S. regulations, such as HIPAA for healthcare data or PCI DSS for payment card information, mandate encryption of sensitive data. Failing to encrypt data, especially when it's stored in the cloud, exposes the organization to severe legal penalties and ethical breaches related to data confidentiality and privacy. Professional reasoning. Professionals facing this situation should adopt a risk-based approach, prioritizing security and compliance from the outset. The decision-making process should involve 1. Understanding the specific data being stored and its sensitivity level. 2. Identifying all applicable U.S. federal and state regulations governing that data. 3. Mapping OCI security services and features to these regulatory requirements. 4. Designing an architecture that implements the principle of least privilege for all access controls, both network and identity-based. 5. Regularly reviewing and auditing access policies and security configurations. 6. Consulting with legal and compliance experts to ensure all requirements are met. This systematic approach ensures that security and compliance are not afterthoughts but are integral to the cloud architecture design, thereby mitigating risks and upholding professional and ethical standards. Question 3. The performance metrics show a consistent increase in API response times for a critical microservice hosted on Oracle Cloud Infrastructure. The architect needs to identify the most effective and compliant strategy to address this latency. Option A. Migrate the entire microservice to a different OCI region to see if network latency is the primary factor, without first investigating the current region's resource utilization. Option B. Conduct a detailed analysis of OCI monitoring metrics for the microservice's compute instances, database connections, and network traffic to identify specific resource constraints or misconfigurations. Based on findings, propose targeted optimizations such as adjusting compute shapes, optimizing database queries, or implementing caching. Option C. Disable security monitoring and logging for the microservice to reduce any potential overhead that might be contributing to the increased response times. Option D. Immediately scale up the compute instances hosting the microservice by increasing their shapes and number, assuming that increased capacity will resolve the latency. The correct answer is B. Conduct a detailed analysis of OCI monitoring metrics for the microservices, compute instances, database connections, and network traffic to identify specific resource constraints or misconfigurations. Based on findings, propose targeted optimizations such as adjusting compute shapes, optimizing database queries, or implementing caching. Explanation. Scenario analysis. The scenario presents a common challenge in cloud architecture, balancing performance optimization with cost efficiency and adherence to security best practices. The architect must interpret performance metrics to identify potential bottlenecks or inefficiencies without compromising the security posture or incurring unnecessary expenses. The professional challenge lies in making informed decisions based on data, understanding the trade-offs involved, and ensuring compliance with Oracle Cloud Infrastructure (OCI) best practices and general cloud security principles. Correct approach analysis. The correct approach involves a systematic investigation of the performance metrics to pinpoint the root cause of the observed latency. This includes examining resource utilization, CPU, memory, network I/O within the OCI compute instances, analyzing database query performance, and reviewing network latency between services. Identifying specific OCI services that are underperforming or misconfigured, and then proposing targeted optimizations such as adjusting compute shapes, optimizing database indexing, or implementing caching mechanisms, represents best professional practice. This approach is aligned with OCI's architectural best practices for performance and cost management, ensuring that solutions are both efficient and effective. It also implicitly supports security by ensuring that resources are not over-provisioned, which can be a security risk, and that performance issues do not lead to denial of service conditions. Incorrect approaches analysis. One incorrect approach would be to immediately scale up all compute instances without a thorough investigation. This is professionally unacceptable because it represents a brute force solution that is likely to be cost inefficient and may not address the actual root cause of the latency. It fails to demonstrate analytical rigor and could lead to significant overspending, violating principles of responsible resource management. Another incorrect approach would be to disable security monitoring tools to reduce overhead, assuming they are contributing to latency. This is a severe regulatory and ethical failure. Security monitoring is a fundamental requirement for protecting cloud resources and data. Disabling such tools without a clear, documented, and risk-assessed justification is a direct violation of security best practices and could expose the organization to significant risks, including data breaches and non-compliance with potential future regulatory requirements for security logging and auditing. A third incorrect approach would be to migrate the entire application to a different OCI region without understanding the cause of the latency. While regional migration can sometimes resolve network-related issues, it is a drastic measure that incurs significant migration effort and cost. Without diagnosing the specific performance bottleneck, this approach is speculative and inefficient, failing to demonstrate a structured problem-solving methodology. It also risks introducing new, unforeseen issues in the new region. Professional reasoning. Professionals should approach performance issues by first establishing a baseline, then collecting and analyzing relevant metrics from OCI monitoring tools. The process should involve hypothesis generation about potential causes, followed by targeted testing and validation. When considering solutions, architects must evaluate them against performance, cost, security, and operational impact. A structured approach, prioritizing root cause analysis over reactive scaling or drastic changes, ensures that solutions are effective, efficient, and maintain the integrity of the cloud environment. Question 4. Quality control measures reveal that a critical customer-facing application hosted on Oracle Cloud Infrastructure is experiencing intermittent and severe performance degradation. As the OCI architect associate, what is the most appropriate initial approach to diagnose and resolve this issue while adhering to best practices for risk management and operational stability? Option A. Implement a broad, untested configuration change across all OCI networking and storage services to see if it resolves the degradation. Option B. Immediately initiate a rollback of all recent application deployments across all environments, assuming a recent change is the cause. Option C. Scale up compute and database resources across the entire OCI tenancy, anticipating that increased capacity will resolve the performance issues. Option D. Conduct a comprehensive review of OCI service health dashboards and application logs, correlating performance metrics with recent events and resource utilization to identify potential bottlenecks or anomalies. Correct answer is B. Immediately initiate a rollback of all recent application deployments across all environments, assuming a recent change is the cause. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture where a critical application's performance is unexpectedly degraded. The professional challenge lies in accurately identifying the root cause of the performance issue without introducing further instability or violating compliance requirements. The urgency to restore service must be balanced with the need for a systematic and evidence-based approach to risk assessment and mitigation. Misdiagnosing the issue could lead to wasted resources, prolonged downtime, and potential data integrity problems, all of which carry significant business and reputational risks. Correct approach analysis. The correct approach involves a structured risk assessment that prioritizes understanding the current state and potential impacts. This begins with gathering detailed telemetry and logs from the affected OCI services. By analyzing this data, architects can identify anomalies, error patterns, or resource constraints that correlate with the performance degradation. This data-driven approach allows for the formulation of hypotheses about the root cause, which can then be tested in a controlled manner. The subsequent step of developing targeted mitigation strategies based on these hypotheses, and then validating their effectiveness through phased rollouts or controlled tests, minimizes the risk of introducing new problems. This aligns with best practices in IT service management and cloud operations, emphasizing proactive monitoring, incident response, and continuous improvement. From a regulatory perspective, maintaining application availability and data integrity are often implicit or explicit requirements, and a systematic risk assessment directly supports these objectives by ensuring that remediation efforts are effective and do not inadvertently cause further harm. Incorrect approaches analysis. Implementing a broad, untested configuration change across all OCI services without a clear understanding of the specific failure points is a significant regulatory and ethical failure. This approach bypasses the crucial step of risk assessment and introduces a high probability of unintended consequences, potentially impacting other critical systems or data. It demonstrates a lack of due diligence and a disregard for the principle of least privilege and controlled change management, which are fundamental to maintaining a secure and stable cloud environment. Such an action could lead to a violation of service-level agreements, SLAs, and potentially breach data protection regulations if it results in data corruption or unauthorized access. Reverting all recent deployments without analyzing their specific impact or necessity is also professionally unsound. While reverting can sometimes resolve issues, doing so indiscriminately ignores the possibility that the performance degradation is unrelated to recent changes or that some recent changes might be beneficial. This approach lacks analytical rigor and can lead to unnecessary disruption and loss of functionality. It fails to demonstrate a commitment to understanding the problem, which is a core tenet of professional responsibility in IT operations. Focusing solely on scaling up resources without identifying the bottleneck is an inefficient and potentially costly approach. While scaling can alleviate performance issues caused by resource contention, it does not address the underlying cause if the problem is, for example, inefficient code, a network latency issue, or a misconfiguration. This approach risks over-provisioning resources, leading to unnecessary expenditure, and may not resolve the performance degradation if the bottleneck lies elsewhere. It represents a failure to conduct a thorough risk assessment and instead opts for a brute force solution that may not be appropriate or effective. Professional reasoning. Professionals should approach such incidents by first establishing a clear incident response framework. This framework should include steps for immediate containment, detailed investigation, root cause analysis, solution development, testing, and deployment. The process should be iterative, with continuous monitoring and validation at each stage. When assessing risks, consider the potential impact on availability, integrity, and confidentiality of data, as well as compliance with relevant regulations. Always prioritize data-driven decision-making, leveraging available telemetry and logs. Document all actions taken and their outcomes to facilitate post-incident reviews and continuous improvement. Question 5. Cost-benefit analysis shows that adopting a new OCI AI service could significantly improve customer service response times, but its integration requires careful consideration of data privacy and regulatory compliance. As an OCI Architect Associate, what is the most prudent approach to recommending the adoption of this service? Option A. Conduct a thorough security and compliance review of the AI service, engaging relevant stakeholders, performing a risk assessment, and planning a phased rollout with continuous monitoring, ensuring alignment with applicable data privacy regulations. Option B. Immediately integrate the AI service into the production environment to capitalize on the projected benefits, assuming Oracle's compliance certifications cover all necessary regulatory requirements. Option C. Recommend against adopting the AI service due to the potential compliance risks, opting for a less efficient but fully understood existing solution. Option D. Prioritize the integration of the AI service based solely on its technical capabilities and projected cost savings, deferring detailed security and compliance checks until after the initial deployment. The correct answer is B. Immediately integrate the AI service into the production environment to capitalize on the projected benefits, assuming Oracle's compliance certifications cover all necessary regulatory requirements. Explanation. This scenario presents a professional challenge due to the inherent tension between rapid innovation and the need for robust security and compliance within Oracle Cloud Infrastructure, OCI. Architects must balance the desire to leverage new OCI services for competitive advantage against the imperative to ensure data protection, regulatory adherence, and operational stability. The challenge lies in making informed decisions about service adoption that are not only technically sound, but also align with the organization's risk appetite and the specific regulatory landscape governing its operations. The correct approach represents best professional practice because it prioritizes a structured, risk-aware evaluation process by engaging stakeholders early, conducting thorough security and compliance reviews, and performing a phased rollout with continuous monitoring. The architect ensures that new services are integrated responsibly. This aligns with the principles of secure by design and compliance by design, which are fundamental to professional cloud architecture. Specifically, within the context of the 1Z0-1072-23 exam, this approach demonstrates an understanding of OCI's shared responsibility model and the importance of proactive governance. The focus on understanding the shared responsibility model is critical, as it dictates the boundaries of security and compliance responsibilities between Oracle and the customer, directly impacting the architect's design choices and operational procedures. An incorrect approach that involves immediately deploying a new service without adequate security vetting would represent a significant regulatory and ethical failure. This could lead to data breaches, non-compliance with regulations such as GDPR or HIPAA, depending on the specific jurisdiction and data handled, and substantial financial penalties. Ethically, it breaches the professional duty to protect client data and maintain system integrity. Another incorrect approach, such as relying solely on vendor claims without independent verification, also poses regulatory risks. If the vendor's security posture or compliance certifications are misrepresented or insufficient for the organization's specific needs, the customer remains liable for any non-compliance. This demonstrates a failure in due diligence and professional responsibility. Professionals should adopt a decision-making framework that begins with clearly defining business objectives and technical requirements. This should be followed by a comprehensive assessment of potential OCI services, including their security features, compliance certifications, and integration capabilities. A critical step is to consult relevant internal stakeholders, security, legal, compliance, and external regulatory guidance. Risk assessment, including threat modeling and impact analysis, is paramount. Finally, a phased implementation strategy with robust testing and monitoring protocols ensures that new services are adopted safely and effectively, minimizing potential regulatory and security pitfalls. Question 6. Strategic planning requires a cloud architect to consider the implications of data residency when designing a new customer-facing application that will handle sensitive user information. Given the application's target audience is primarily within a specific European Union member state, which of the following actions best ensures compliance with relevant data protection regulations? Option A. Select an Oracle Cloud Infrastructure, OSI, region that is geographically closest to the majority of the target users, assuming it will offer the best performance and implicitly meet compliance needs. Option B. Verify that the chosen OCI region and its associated services are certified to meet the specific data residency and processing requirements mandated by the European Union's General Data Protection Regulation, GDPR, and the laws of the target member state. Option C. Proceed with deploying the application to the nearest OCI region without explicit confirmation of its data residency compliance, prioritizing rapid deployment to meet business deadlines. Option D. Assume that all OCI regions provide a uniform level of data protection and residency compliance, making the specific region choice secondary to technical performance. The correct answer is A. Select an Oracle Cloud Infrastructure, OSI, region that is geographically closest to the majority of the target users, assuming it will offer the best performance and implicitly meet compliance needs. Explanation: Scenario analysis. This scenario presents a professional challenge where a cloud architect must balance the immediate business need for rapid deployment with the long-term implications of data residency and compliance. The pressure to deliver quickly can lead to overlooking critical regulatory requirements, potentially exposing the organization to significant legal and financial penalties. The architect's responsibility extends beyond technical implementation to ensuring adherence to the governing regulatory framework. Correct approach analysis. The correct approach prioritizes understanding and adhering to the Oracle Cloud Infrastructure, OSI, service level agreements SLAs, and the relevant data residency regulations for the target audience of the application. This involves verifying that the chosen OCI region and its associated services meet the specific data sovereignty requirements mandated by the jurisdiction where the data will be processed and stored. This aligns with the principle of due diligence and responsible cloud architecture, ensuring that the solution is not only technically sound, but also legally compliant. Incorrect approaches analysis. Choosing an OCI region solely based on proximity or perceived performance without verifying its compliance with data residency laws is a significant regulatory failure. This approach disregards the legal obligations of the organization and could lead to data being stored in a jurisdiction that does not offer the required level of protection or is subject to different, potentially less stringent, regulations. Deploying the application to the closest OCI region without consulting legal or compliance teams demonstrates a lack of understanding of the architect's broader responsibilities. This bypasses essential checks and balances, creating a high risk of noncompliance with data protection laws, such as those that might govern the handling of personally identifiable information, PI, or sensitive financial data. Relying on the assumption that all OCI regions offer equivalent compliance guarantees is a dangerous oversimplification. Different regions may have varying certifications, data processing agreements, and adherence to specific jurisdictional mandates. Failing to confirm this can lead to inadvertent violations of data residency and privacy regulations. Professional reasoning. Professionals should adopt a risk-based approach. Before selecting any cloud service or region, they must identify all applicable regulatory requirements. This involves proactive engagement with legal, compliance, and business stakeholders to define data residency needs. The decision-making process should then involve mapping these requirements to the capabilities and compliance certifications of available OCI regions and services, documented through a formal review process. Question 7. Which approach would be most effective for an Oracle Cloud Infrastructure architect tasked with designing the network for a latency-sensitive, high-throughput financial trading application, considering performance, security, and cost-effectiveness? Option A. Select the most cost-effective OCI networking option available, prioritizing minimal expenditure over specific performance or security features. Option B. Implement Oracle Cloud Infrastructure Fast Connect with a dedicated private connection to the on-premises data center, coupled with OCI Virtual Cloud Network, VCN, security lists, and network security groups for granular traffic control. Option C. Deploy OCI load balancing for all incoming traffic and use OCI Web Application Firewall, WAF, to manage network security, without specific consideration for dedicated network connectivity. Option D. Utilize OCI VPN Connect for secure connectivity, and rely solely on OCI network security groups for all ingress and egress traffic filtering. The correct answer is B. Implement Oracle Cloud Infrastructure, fast connect with a dedicated private connection to the on-premises data center, coupled with OCI Virtual Cloud Network, VCN, security lists and network security groups for granular traffic control. Explanation. This scenario presents a professional challenge in selecting the most appropriate Oracle Cloud Infrastructure, OCI networking service for a critical application, balancing performance, security, and cost. The architect must consider the specific requirements of the application, which include low latency, high bandwidth, and robust security, while adhering to OCI best practices and the implicit need for cost-effectiveness without compromising functionality. The challenge lies in understanding the nuanced differences between OCI networking services and how they map to these requirements. The correct approach represents best professional practice because it prioritizes a thorough understanding of the application's specific needs and then maps those needs to the most suitable OCI networking service. This involves evaluating the trade-offs between different services, considering factors like dedicated connectivity, network segmentation, and traffic management. By selecting a service that directly addresses the application's performance and security demands, the architect ensures optimal functionality and minimizes potential risks. This aligns with the principle of designing solutions that are fit for purpose and adhere to OCI architectural best practices, which are implicitly guided by principles of efficiency and security. An incorrect approach that focuses solely on cost without adequately considering performance and security would represent a regulatory and ethical failure. While cost optimization is important, compromising critical application performance or security due to an overly simplistic cost-driven decision can lead to business disruption, data breaches, or non-compliance with potential future regulatory mandates related to data integrity and availability. Similarly, an approach that over-engineers the solution by selecting a service with capabilities far beyond the application's needs, while seemingly secure, would be professionally unsound due to unnecessary cost and complexity, potentially hindering future agility and maintainability. Another incorrect approach might be to choose a service based on familiarity rather than a rigorous evaluation of its suitability for the specific application's unique requirements, leading to suboptimal performance or security gaps. Professionals should employ a decision-making framework that begins with a detailed requirements gathering phase. This involves understanding the application's functional and non-functional requirements, including performance metrics, security posture, and scalability needs. Subsequently, an evaluation of available OCI services should be conducted, comparing their features, benefits, and limitations against the gathered requirements. This comparative analysis should consider not only technical specifications, but also cost implications and operational overhead. The final decision should be a well-reasoned choice that demonstrably meets the application's needs while adhering to OCI best practices and organizational objectives. Question 8. The review process indicates that a financial services client requires their sensitive customer data to be stored and processed exclusively within the European Union, in compliance with GDPR and other relevant EU data protection regulations. The proposed OCI architecture involves deploying a database service and compute instances to host their application, which architectural strategy best ensures adherence to these strict data residency requirements. Option A. Deploy the database service and compute instances within OCI regions located exclusively within the European Union and configure network security groups to restrict egress traffic to only authorized EU endpoints. Option B. Utilize OCI's global load balancing to distribute traffic across multiple OCI regions worldwide and rely on the client's application logic to filter data based on its origin. Option C. Encrypt all sensitive customer data at rest and in transit, and deploy the database service and compute instances in any OCI region, assuming encryption negates the need for geographical data control. Option D. Deploy the database service and compute instances in an OCI region outside the European Union for potentially lower latency, and inform the client that they are responsible for ensuring their data remains compliant. The correct answer is A. Deploy the database service and compute instances within OCI regions located exclusively within the European Union, and configure network security groups to restrict egress traffic to only authorized EU endpoints. Explanation. The review process indicates a need to ensure that sensitive data stored within Oracle Cloud Infrastructure, OCI, adheres to specific data residency and sovereignty requirements. This scenario is professionally challenging because architectural decisions directly impact compliance with potential legal and regulatory obligations regarding where data can be stored and processed. Misinterpreting or ignoring these requirements can lead to significant legal penalties, reputational damage, and loss of customer trust. The correct approach involves leveraging OCI's regional capabilities to enforce data residency. By strategically deploying resources within specific OCI regions that align with the client's data sovereignty mandates, an architect can ensure that data remains within the defined geographical boundaries. This aligns with best professional practice by proactively addressing compliance needs through architectural design, demonstrating due diligence, and safeguarding the client's legal standing. This approach is ethically sound as it prioritizes client protection and adherence to established legal frameworks. An incorrect approach would be to assume that OCI's global network inherently satisfies all data residency needs without explicit configuration. This fails to acknowledge that while OCI has a global presence, data can be replicated or accessed across regions unless specifically constrained. This oversight represents a regulatory failure by potentially violating data sovereignty laws, which often mandate that certain types of data must reside within a specific country or jurisdiction. Ethically, it demonstrates a lack of diligence in protecting client data and their legal obligations. Another incorrect approach is to rely solely on encryption without considering the physical location of the data. While encryption is crucial for data security, it does not address data residency requirements. Data encrypted and stored in a non-compliant region still violates data sovereignty laws. This is a regulatory failure because it conflates data security with data location, leading to non-compliance with jurisdiction-specific mandates. A third incorrect approach is to delegate the responsibility of data residency compliance entirely to the client without providing architectural guidance. While the client ultimately owns their compliance obligations, an OCI architect has a professional responsibility to design solutions that facilitate compliance. Failing to do so, and simply stating that the client must manage it, is an abdication of professional duty and can lead to non-compliant architectures. This is an ethical failure as it neglects the architect's role in enabling secure and compliant cloud deployments. The professional reasoning process for similar situations should involve 1. Understanding the client's specific data residency and sovereignty requirements upfront. 2. Mapping these requirements to OCI's regional offerings and service capabilities. 3. Designing the OCI architecture to explicitly enforce these constraints, utilizing features like region selection for services and network controls. 4. Documenting the architectural decisions and their rationale in relation to compliance. 5. Communicating potential risks and limitations to the client, ensuring they are aware of their ongoing responsibilities. Question 9. The analysis reveals that a financial services firm is migrating its core banking application to Oracle Cloud Infrastructure and must ensure strict adherence to data residency laws that mandate all customer financial data remain within the European Union. The firm also needs to maintain high availability and disaster recovery capabilities. Which OCI strategy best aligns with these requirements while adhering to regulatory frameworks? Option A. Deploying the application and its associated data across multiple OCI regions within the European Union, utilizing OCI's cross-region disaster recovery features to ensure high availability and compliance with data residency. Option B. Utilizing OCI's edge locations for data storage to minimize latency for all users, irrespective of their geographic location, and assuming this satisfies data residency requirements. Option C. Deploying the application in a single OCI region within the European Union and relying solely on OCI's global network for data redundancy, without explicitly configuring cross-region replication. Option D. Deploying the application in an OCI region outside the European Union to leverage potentially lower latency for global users, and implementing application-level encryption for data protection. Correct answer is A. Deploying the application and its associated data across multiple OCI regions within the European Union, utilizing OCI's cross-region disaster recovery features to ensure high availability and compliance with data residency. Explanation. The analysis reveals a common challenge in cloud architecture. balancing the need for robust security and compliance with the operational efficiency and cost-effectiveness of cloud services. Specifically, the scenario involves a financial services organization that must adhere to strict data residency and privacy regulations, which are paramount in this industry. The challenge lies in selecting the appropriate Oracle Cloud Infrastructure (OSI) services and configurations to meet these stringent requirements without unduly hindering application performance or increasing operational overhead. The correct approach involves a thorough understanding of OCI's regional capabilities, data sovereignty features, and compliance certifications relevant to financial services. Best professional practice dictates a proactive, risk-based approach that prioritizes regulatory adherence. This includes leveraging OCI's global infrastructure to deploy resources within the required geographic boundaries, utilizing encryption services for data at rest and in transit, and implementing robust access control mechanisms. Adhering to these principles ensures that the organization not only meets its legal obligations, but also maintains customer trust and avoids significant penalties. An incorrect approach would be to prioritize cost savings or ease of deployment over regulatory mandates. For instance, deploying resources in a region that does not meet data residency requirements, even if it offers lower costs, represents a direct violation of data sovereignty laws. Similarly, neglecting to implement appropriate encryption or access controls, assuming that OCI's inherent security is sufficient, would be a failure to implement due diligence and could lead to data breaches, violating privacy regulations and industry standards. Another incorrect approach might be to assume that a single compliance certification covers all regulatory needs, without verifying its applicability to the specific data types and processing activities involved. This oversight can lead to non-compliance with nuanced regulatory requirements. Professionals should employ a decision-making framework that begins with a comprehensive understanding of all applicable regulations. This should be followed by an assessment of OCI services and features that directly address these requirements, considering factors like data residency, encryption, access management, and auditability. A comparative analysis of different OCI deployment strategies and service configurations, evaluating each against the regulatory checklist and business objectives, is crucial. Finally, continuous monitoring and periodic reevaluation of the architecture are essential to adapt to evolving regulations and OCI service updates. Question 10. Cost-benefit analysis shows that a new Oracle Cloud Infrastructure service offers significant operational cost reduction for processing sensitive U.S. federal government data, but the architect must ensure the chosen OCI region strictly adheres to U.S. data residency regulations. Which of the following actions best demonstrates professional responsibility and regulatory compliance? Option A. Rely on the general compliance statements provided by Oracle for the OCI platform, without specifically validating the data residency of the chosen region for U.S. federal government data. Option B. Verify that the selected OCI region is within the United States and that the specific OCI service has been certified for use with U.S. federal government data, ensuring data remains within U.S. borders as per regulatory mandates. Option C. Implement the new service in an OCI region outside the United States to leverage potentially lower costs, with the understanding that data can be encrypted in transit and at rest. Option D. Proceed with the service deployment in the closest OCI region to the data source to minimize latency, assuming that all U.S. regions inherently meet federal data residency requirements. Correct answer is B. Verify that the selected OCI region is within the United States and that the specific OCI service has been certified for use with U.S. federal government data, ensuring data remains within U.S. borders as per regulatory mandates. Explanation. This scenario presents a common challenge for cloud architects, balancing the immediate cost savings of a new service with the long-term implications for data residency and compliance. The core of the challenge lies in the architect's responsibility to not only design for technical efficiency, but also to ensure adherence to regulatory frameworks governing data handling. The 1Z0-1072-23 exam syllabus emphasizes understanding Oracle Cloud Infrastructure services and their implications within a given regulatory context. In this case, the architect must consider the specific data residency requirements mandated by U.S. federal regulations for government data. The correct approach prioritizes understanding and adhering to the specified regulatory framework. By confirming that the chosen OCI region and services meet the data residency requirements for U.S. government data, the architect upholds professional responsibility and avoids potential legal and financial penalties associated with noncompliance. This aligns with best practices in cloud architecture, where security and compliance are foundational, not afterthoughts. The regulatory framework for U.S. government data, particularly concerning data residency, is stringent and requires explicit validation of where data is stored and processed. An incorrect approach that overlooks or misinterprets data residency requirements poses significant regulatory and ethical failures. For instance, assuming a service is compliant without explicit verification can lead to violations of data sovereignty laws, potentially resulting in severe fines, reputational damage, and loss of trust. Another incorrect approach might be to prioritize cost savings over compliance, which is a direct ethical breach. Professionals are expected to act in the best interest of their organization and its stakeholders, which includes safeguarding against regulatory noncompliance. A third incorrect approach could be to rely on generic compliance statements without understanding the specific nuances of the data being handled and the applicable regulations. This demonstrates a lack of due diligence and a failure to apply critical thinking to the problem. The professional decision-making process in such situations should involve a structured approach. 1. Identify and understand all applicable regulatory requirements, paying close attention to data residency, data sovereignty, and data protection mandates. 2. Thoroughly research the capabilities and limitations of the proposed OCI services and regions in relation to these requirements. 3. Consult with legal and compliance teams to validate the understanding of regulations and the proposed solutions' adherence. 4. Document all decisions, justifications, and validation steps to ensure transparency and auditability. 5. Prioritize compliance and security over short-term cost benefits when there is a conflict. Question 11. Quality control measures reveal that a critical customer-facing web application deployed on Oracle Cloud infrastructure is experiencing intermittent performance issues, leading to user complaints. The current compute shape allocated to the application is a general-purpose instance. The architecture team needs to determine the most appropriate next step to address these performance concerns, while ensuring cost-effectiveness and maintaining security best practices. Option A. Analyze the application's resource utilization metrics, CPU, memory, network I/O, to identify bottlenecks and select a compute shape that better matches the identified requirements, prioritizing general-purpose shapes that offer a balanced resource profile. Option B. Re-architect the application to run on a specialized compute shape designed for high-performance computing, as this will guarantee superior performance for all workloads. Option C. Downgrade to the smallest available compute shape to reduce costs, assuming the performance issues are due to over-provisioning. Option D. Immediately upgrade to the largest and most powerful compute shape available in OCI to ensure maximum performance and eliminate any potential resource constraints. The correct answer is A. Analyze the application's resource utilization metrics, CPU, memory, network I/O, to identify bottlenecks and select a compute shape that better matches the identified requirements, prioritizing general-purpose shapes that offer a balanced resource profile. Explanation: Scenario analysis. This scenario presents a professional challenge in selecting the most appropriate Oracle Cloud infrastructure, OCI, compute shape for a critical application. The challenge lies in balancing performance requirements, cost optimization, and adherence to security best practices, all within the context of the 1Z0-1072-23 exams implied regulatory and compliance considerations for cloud deployments. Architects must make informed decisions that not only meet technical needs, but also align with potential industry standards for resource utilization and security posture, even if not explicitly stated as a specific jurisdiction's law in this context. Correct approach analysis. Choosing a compute shape that offers a balance of CPU, memory, and network resources, and is specifically designed for general-purpose workloads, represents best professional practice. This approach demonstrates an understanding of workload characteristics and the need for a stable, predictable performance baseline. It aligns with the principle of selecting the right tool for the job without over-provisioning, which is a key aspect of responsible cloud resource management and cost efficiency. This also indirectly supports compliance by avoiding unnecessary resource exposure and potential security vulnerabilities associated with overly powerful or inappropriately specialized instances. Incorrect approach is analysis. Selecting the smallest available compute shape without a thorough analysis of the application's actual resource demands is a regulatory and ethical failure. This can lead to performance degradation, application instability, and ultimately, a failure to meet service-level agreements, SLAs, which can have significant business and reputational consequences. It also represents a failure in due diligence and professional responsibility to adequately assess requirements. Opting for the largest, most powerful compute shape available, regardless of actual need, is also professionally unacceptable. This leads to significant cost overruns and represents inefficient resource utilization, which can be viewed as a breach of fiduciary duty if the architect is responsible for managing cloud spend. From a security perspective, it unnecessarily increases the attack surface and potential impact of any security compromise. Choosing a compute shape optimized for a completely different workload type, such as high-performance computing or dense I/O, without a clear justification based on the application's specific needs, is a failure in technical judgment. This can result in suboptimal performance, increased costs due to inefficient resource allocation, and potential compatibility issues, all of which undermine the architect's professional credibility and the reliability of the deployed solution. Professional reasoning. Professionals should approach compute shape selection by first conducting a comprehensive assessment of the application's resource requirements, CPU, memory, network, storage I/O. This involves understanding the application's peak and average usage patterns. Next, they should consult OCI documentation to understand the characteristics and intended use cases of various compute shapes. A comparative analysis of suitable general-purpose shapes, considering performance benchmarks and cost implications, is crucial. The decision should prioritize meeting functional requirements while optimizing for cost and adhering to security best practices. This iterative process of assessment, comparison, and selection ensures a well-reasoned and professionally sound outcome. Question 12. During the evaluation of a new cloud architecture for a financial services organization deploying multiple distinct applications across OCI, which IAM strategy best balances granular access control, operational efficiency, and adherence to the principle of least privilege, considering the need for robust auditing and compliance with financial regulations? Option A. Grant broad administrative privileges at the root compartment level to simplify initial setup and allow flexibility for future development. Option B. Assign individual user ACID to policies for each resource across all projects to ensure explicit control over every access request. Option C. Rely solely on OCI Vault for managing all secrets and access credentials without a defined IAM policy structure for resource access. Option D. Implement compartment-based IAM policies, utilizing dynamic groups and instance principles for compute resources to enforce least privilege and streamline management across projects. The correct answer is D. Implement compartment-based IAM policies, utilizing dynamic groups and instance principles for compute resources to enforce least privilege and streamline management across projects. Explanation. Scenario analysis. This scenario presents a professional challenge in selecting the most appropriate Oracle Cloud Infrastructure, OSI, Identity and Access Management, IAM, strategy for a multi-project environment with varying security and compliance needs. The challenge lies in balancing granular control, operational efficiency, and adherence to the principle of least privilege, all while considering the specific regulatory context implied by the exam's jurisdiction. The architect must make a judgment call that impacts security posture, cost, and manageability. Correct approach analysis. The correct approach leverages OCI's IAM policies to grant permissions at the compartment level, utilizing dynamic groups and instance principles for compute resources. This strategy aligns with best professional practices by 1. Implementing the principle of least privilege. Permissions are granted only to the resources and actions necessary for each project's function, minimizing the attack surface. 2. Enhancing security. Compartments provide a logical isolation boundary, and policies applied at this level ensure that resources within a compartment inherit those permissions. Dynamic groups and instance principles automate credential management for compute instances, reducing the risk of hard-coded secrets. 3. Improving manageability. Centralized policy management within compartments simplifies administration and auditing. 4. Supporting compliance. This structured approach makes it easier to demonstrate compliance with regulatory requirements that mandate segregation of duties and controlled access to sensitive data. Incorrect approaches analysis. Granting broad permissions at the root compartment level is a significant regulatory and ethical failure. It violates the principle of least privilege, exposing all resources to potentially excessive access. This increases the risk of unauthorized modifications or data breaches, making it difficult to meet compliance mandates that require strict access controls. Assigning individual user ACID to policies for each resource across multiple projects is operationally inefficient and prone to errors. It creates a management burden, making it difficult to revoke access when personnel change roles or leave the organization. This lack of scalability and auditability is a professional failing, as it hinders effective governance and compliance. Relying solely on OCI Vault for secret management without a corresponding IAM policy structure for resource access is incomplete. While OCI Vault is crucial for secure secret storage, it does not inherently control which OCI resources can access those secrets or what actions they can perform. Without proper IAM policies, access to secrets can be too broad, undermining the overall security posture. Professional reasoning. Professionals should adopt a systematic decision-making process when designing OCI IAM strategies. This involves 1. Understanding business and compliance requirements. Clearly define the security and regulatory obligations for each project. 2. Applying the principle of least privilege. Design policies that grant only the minimum necessary permissions. 3. Leveraging OCI's IAM constructs. Utilize compartments, groups, dynamic groups, and instance principles effectively. 4. Automating where possible. Employ dynamic groups and instance principles to reduce manual effort and potential for error. 5. Regularly reviewing and auditing. Periodically assess IAM policies to ensure they remain aligned with current needs and compliance standards. 6. Considering the operational impact. Choose solutions that are manageable and scalable. Question 13. The audit findings indicate that sensitive customer data, subject to strict data residency requirements in a specific European Union member state, is being processed and stored across multiple OCI regions without adequate justification or adherence to jurisdictional boundaries. As an OCI architect, what is the most appropriate course of action to rectify this compliance issue? Option A. Implement a robust data masking and anonymization strategy across all OCI regions where the data is currently stored, rendering it non-personally identifiable before global distribution. Option B. Migrate all sensitive customer data to OCI's object storage in a single, globally distributed region, relying on OCI's inherent security features to protect the data regardless of its physical location. Option C. Deploy a custom data governance solution that encrypts all data at rest and in transit, allowing it to be stored and processed in any OCI region without geographical constraints. Option D. Reconfigure the application to exclusively utilize OCI services within the designated EU region that aligns with the data residency laws, ensuring all data processing and storage for this customer remains within that jurisdiction. Correct answer is D. Reconfigure the application to exclusively utilize OCI services within the designated EU region that aligns with the data residency laws, ensuring all data processing and storage for this customer remains within that jurisdiction. Explanation. Scenario analysis. The audit findings highlight a critical gap in data residency and compliance for sensitive customer data hosted on Oracle Cloud Infrastructure, OCI. The challenge lies in balancing the need for global accessibility and performance with strict adherence to data sovereignty regulations, which can vary significantly by region. Architects must navigate complex legal and technical requirements to ensure data is stored and processed only within approved geographical boundaries, preventing potential legal penalties, reputational damage, and loss of customer trust. Correct approach analysis. Implementing OCI's region-specific services and policies, such as deploying resources exclusively within a designated OCI region that aligns with the applicable data residency laws, represents best professional practice. This approach directly addresses the audit findings by ensuring that data remains within the legally mandated jurisdiction. It leverages OCI's built-in capabilities for regional control, demonstrating a proactive and compliant design. This aligns with the principle of privacy by design and ensures that the cloud architecture is fundamentally built to meet regulatory obligations. Incorrect approach is analysis. Storing all customer data in a single, globally distributed OCI region without explicit consideration for data residency laws is a regulatory failure. This approach ignores the core requirement of data sovereignty and risks violating regulations that mandate data be kept within specific geographical borders. It demonstrates a lack of due diligence in understanding and applying relevant legal frameworks. Utilizing OCI's Content Delivery Network, CDN, to cache sensitive customer data in multiple edge locations worldwide, even if the primary storage is compliant, is an ethical and regulatory failure. Caching data outside of the approved jurisdiction, even for performance reasons, can still constitute a breach of data residency requirements, depending on the specific regulations. This approach prioritizes performance over compliance without proper risk assessment and mitigation. Implementing a custom encryption solution that encrypts data before it leaves the customer's on-premises environment, but then stores it in any OCI region without regard for data residency laws, is a partial but ultimately insufficient approach. While encryption is a vital security measure, it does not inherently satisfy data residency requirements. Data must still reside within the legally permissible geographical boundaries, regardless of its encrypted state. This approach fails to address the fundamental jurisdictional aspect of the audit findings. Professional reasoning. Professionals should approach such scenarios by first thoroughly understanding the specific data residency regulations applicable to the customer's data and their business operations. This involves consulting legal counsel and compliance officers. Subsequently, they must map these requirements to OCI's service offerings and regional capabilities. The design process should prioritize compliance from the outset, selecting OCI regions that meet data sovereignty mandates. Regular audits and continuous monitoring of resource deployment and data flow are essential to maintain compliance. When in doubt, architects should err on the side of caution and seek expert advice rather than making assumptions that could lead to regulatory violations. Question 14. Compliance review shows that several OCI compute instances are consistently running at significantly lower utilization levels than their provision capacity, leading to potential cost inefficiencies. As an OCI architect associate, what is the most appropriate strategy to address this finding while adhering to best practices for resource optimization? Option A. Manually resize compute instances to a smaller fixed size during off-peak hours and revert to larger sizes during peak hours. Option B. Provision all compute instances to the maximum capacity required for peak load scenarios to ensure consistent availability. Option C. Document the current resource allocation and defer any changes until a future major architectural review. Option D. Implement OCI auto-scaling policies based on observed utilization metrics to dynamically adjust the number or size of compute instances. The correct answer is D. Implement OCI auto-scaling policies based on observed utilization metrics to dynamically adjust the number or size of compute instances. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture, where the need for efficient resource utilization and cost optimization must be balanced against performance and availability requirements. The compliance review highlights a potential gap in proactive monitoring and optimization, which can lead to unnecessary expenditure and potentially impact service levels if not addressed. The challenge lies in identifying the root cause of the observed resource overprovisioning and implementing a sustainable solution without disrupting existing operations or introducing new compliance risks. Correct approach analysis. The correct approach involves a systematic analysis of resource utilization patterns and the implementation of automated scaling policies. This represents best professional practice because it directly addresses the identified issue of overprovisioning by dynamically adjusting resources based on actual demand. Oracle Cloud Infrastructure, OCI, provides robust tools for monitoring, e.g., OCI monitoring, application performance monitoring, and auto-scaling, e.g., compute auto-scaling. By leveraging these native OCI services, architects can ensure that resources are provisioned only when needed and scaled down when demand decreases, leading to significant cost savings and improved efficiency. This proactive and data-driven approach aligns with the principles of responsible cloud resource management and operational excellence, which are implicitly expected within the scope of OCI architectural best practices. Incorrect approaches analysis. Manually adjusting resource sizes without a clear understanding of demand fluctuations is an inefficient and reactive approach. It fails to address the root cause of overprovisioning and can lead to either continued overspending or underprovisioning, impacting performance. This approach lacks the systematic analysis and automation crucial for effective cloud resource management. Implementing a fixed, larger resource size across all environments, even if it accommodates peak loads, directly contradicts the principles of cost optimization and efficient resource utilization. This is a wasteful practice that incurs unnecessary costs and does not leverage the elasticity of the cloud. It represents a failure to apply architectural best practices for cost management. Ignoring the compliance review findings and continuing with the current resource allocation is a direct ethical and professional failure. It demonstrates a disregard for identified inefficiencies and potential cost overruns, which can have financial implications for the organization. This approach neglects the responsibility of an architect to ensure efficient and cost-effective cloud deployments. Professional reasoning. Professionals should approach such situations by first acknowledging the findings of the compliance review. The next step is to gather data through OCI monitoring tools to understand the actual resource utilization patterns over a representative period. This data should then inform the design of auto-scaling policies for compute instances and other relevant services. The decision-making process should prioritize solutions that are automated, data-driven, and leverage native OCI capabilities for cost optimization and performance management. Regular review and refinement of these policies based on ongoing monitoring are essential for sustained efficiency. Question 15. Research into the impact of migrating a customer's sensitive financial data to Oracle Cloud infrastructure reveals potential architectural choices. The organization is subject to stringent financial data protection regulations. Which architectural approach best ensures compliance and minimizes risk during and after the migration? Option A. Design the cloud architecture using OCI services that offer the highest performance and scalability, assuming that post-migration security audits will identify and address any compliance deviations. Option B. Implement the migration using a lift-and-shift approach for existing on-premises applications, relying on the inherent security of OCI to meet all regulatory obligations without further architectural adjustments. Option C. Prioritize the selection of OCI services based on their cost-effectiveness and ease of integration, deferring detailed regulatory impact assessments until after the migration is complete. Option D. Engage legal and compliance teams early in the design phase to identify all applicable financial data protection regulations. Map these requirements to specific OCI security and data residency features, and incorporate these into the core architecture. The correct answer is A. Design the cloud architecture using OCI services that offer the highest performance and scalability, assuming that post-migration security audits will identify and address any compliance deviations. Explanation. This scenario presents a professional challenge due to the inherent complexity of assessing the impact of cloud migration on an organization's compliance posture, particularly when dealing with sensitive data. Architect must balance the benefits of cloud adoption with the stringent regulatory requirements governing data handling and security. Careful judgment is required to ensure that the migration not only enhances operational efficiency, but also maintains or improves compliance with relevant regulations. The correct approach represents best professional practice because it proactively identifies and mitigates potential compliance risks before they materialize. By engaging with legal and compliance teams early, the architect ensures that the cloud architecture is designed with regulatory mandates at its core. This aligns with the principle of compliance by design, a cornerstone of responsible cloud adoption. Specifically, for the 1Z0-1072-23 exam, this implies adherence to Oracle Cloud Infrastructure's shared responsibility model and understanding how OCI services can be configured to meet specific compliance frameworks, e.g., GDPR, HIPAA, PCI DSS, depending on the data processed and the industry. The proactive engagement ensures that the chosen OCI services and their configurations are validated against these frameworks, preventing costly remediation or breaches. An incorrect approach that focuses solely on technical feasibility without considering regulatory implications is professionally unacceptable. This failure stems from a disregard for legal and ethical obligations, potentially leading to noncompliance, significant fines, reputational damage, and loss of customer trust. For instance, migrating sensitive data to OCI services without understanding the data residency requirements or the specific security controls mandated by regulations would be a direct violation. Another incorrect approach, which relies on post-migration audits to identify compliance gaps, is reactive and inherently risky. This approach assumes that compliance can be retroactively achieved, which is often not the case, and can lead to significant disruption and penalties. It demonstrates a lack of foresight and a failure to integrate compliance into the architectural design process, which is a critical ethical and professional failing in cloud architecture. The professional decision-making process for similar situations should involve a structured risk assessment framework. This begins with understanding the data's sensitivity and the applicable regulatory landscape. Next, it involves mapping these requirements to the capabilities and responsibilities within Oracle Cloud infrastructure. Collaboration with legal, compliance, and security stakeholders is paramount throughout the design and implementation phases. Finally, continuous monitoring and auditing are essential to ensure ongoing compliance. Question 16. The efficiency study reveals that a multinational corporation's Oracle Cloud infrastructure, OCI, deployment is experiencing performance bottlenecks and potential compliance risks related to data residency. The company operates in the European Union, Canada, and Australia, and collects sensitive customer data in each of these regions. The primary objective is to architect a solution that ensures data is stored and processed in compliance with the respective data residency laws of the EU, e.g., GDPR, Canada, e.g., PIPEDA, and Australia, e.g., Privacy Act 1988, while also optimizing for performance and cost-effectiveness. Which of the following architectural approaches best addresses these requirements? Option A. Implement a single, global OCI region for all customer data storage and processing to simplify management and reduce operational overhead, assuming that OCI's general security measures are sufficient for all jurisdictions. Option B. Design the OCI architecture to utilize OCI regions that are geographically located within the EU for EU customer data, within Canada for Canadian customer data, and within Australia for Australian customer data, ensuring appropriate data access controls and network configurations are in place for interregion communication where necessary and legally permissible. Option C. Distribute customer data across various OCI regions globally, prioritizing regions with the lowest OCI service costs, without explicit consideration for the specific data residency laws of the EU, Canada, or Australia. Option D. Deploy OCI resources, including databases and object storage containing customer data, exclusively within OCI regions located in the European Union, leveraging OCI's global network for access from other countries. The correct answer is D. Deploy OCI resources, including databases and object storage containing customer data, exclusively within OCI regions located in the European Union, leveraging OCI's global network for access from other countries. Explanation. The efficiency study reveals a critical need to optimize data residency and compliance for a multinational corporation's Oracle Cloud infrastructure, OCI, deployment. The scenario is professionally challenging because it requires balancing performance, cost, and stringent regulatory requirements across different geographical regions. Architects must ensure that data is stored and processed in compliance with the specific laws of each jurisdiction where the company operates, without compromising the integrity or accessibility of the data. This necessitates a deep understanding of OCI's global infrastructure and its implications for data sovereignty. The correct approach represents best professional practice because it prioritizes adherence to the principle of data localization and sovereignty, which is a fundamental tenet of data protection regulations in many jurisdictions. By strategically placing OCI resources within specific regions that align with data residency mandates, the architecture ensures legal compliance and mitigates the risk of regulatory penalties. This proactive approach demonstrates a commitment to responsible data stewardship and builds trust with customers and regulatory bodies. It also leverages OCI's regional capabilities to potentially improve latency for users within those specific regions. an incorrect approach that involves storing sensitive customer data in a single, central OCI region without considering the data residency laws of other operating countries is a significant regulatory and ethical failure. This violates the principle of data localization, which mandates that certain types of data must reside within the borders of the country where it was collected or where the data subject resides. Such a failure can lead to severe legal consequences, including substantial fines, reputational damage, and loss of customer trust. It also exposes the organization to risks associated with cross-border data transfer regulations, which often have strict requirements for consent and data protection mechanisms. Another incorrect approach, which is to deploy resources across multiple OCI regions without a clear strategy for data placement and access control, also poses regulatory risks. While this might seem like a way to achieve high availability or performance, it can inadvertently lead to data being processed or stored in jurisdictions that do not have adequate data protection laws, or where such processing violates local regulations. Without proper governance, this can result in non-compliance with data sovereignty laws and expose the organization to data breach risks due to inconsistent security controls across regions. The professional reasoning process for this situation should involve a thorough assessment of all applicable data protection regulations in every jurisdiction where the company operates. This includes understanding requirements related to data localization, cross-border data transfers, and the rights of data subjects. Architects should then map these requirements to OCI's regional offerings, identifying the most appropriate OCI regions for different types of data and workloads. A robust data governance framework, including clear policies on data classification, access control, and data lifecycle management, is essential to ensure ongoing compliance. Regular audits and reviews of the OCI deployment against evolving regulatory landscapes are also critical components of best practice. Question 17. The review process indicates that a newly deployed OCI database instance, intended to store sensitive customer financial data, has been configured with Network Security Group (NSG) rules that allow ingress traffic on its standard database port from a broad range of sources. The architect is tasked with re-evaluating these rules to ensure robust security and compliance. Which of the following approaches best adheres to OCI best practices and regulatory expectations for protecting sensitive data? Option A. Disable the Network Security Group entirely for the database subnet to simplify network management and ensure unrestricted access for all OCI services. Option B. Configure the NSG to allow ingress traffic on the database port only from specific trusted IP addresses or CIDR blocks that are known to host authorized application servers and management workstations. Option C. Configure the NSG to allow ingress traffic on the database port from all IP addresses within the OCI region, regardless of the source subnet or compartment. Option D. Configure the NSG to allow ingress traffic on the database port from any source 0.0.0.0/0 to ensure that all legitimate application connections can be established without interruption. The correct answer is B. Configure the NSG to allow ingress traffic on the database port only from specific, trusted IP addresses or CIDR blocks that are known to host authorized application servers and management workstations. Explanation. The review process indicates a potential misconfiguration in the Network Security Group (NSG) rules for a critical Oracle Cloud Infrastructure OCI database deployment. This scenario is professionally challenging because a misconfigured NSG can lead to unauthorized access, data breaches, or denial of service attacks, all of which have significant financial and reputational consequences. The architect must balance security requirements with operational needs, ensuring that only necessary traffic is permitted while maintaining application functionality. Careful judgment is required to avoid overly restrictive rules that hinder legitimate operations or overly permissive rules that create vulnerabilities. The correct approach, which involves implementing the principle of least privilege by allowing only specific ingress traffic from known, trusted sources to the database's required ports, represents best professional practice. This aligns with OCI's security best practices and general cloud security principles. By explicitly defining allowed source IP addresses or CIDR blocks and the specific destination ports, e.g., 1521 for Oracle database, the NSG minimizes the attack surface. This proactive security measure is crucial for protecting sensitive data and maintaining compliance with data protection regulations, which mandate safeguarding sensitive information from unauthorized access. An incorrect approach that involves opening the database port to all ingress traffic, 0.0.0.0/0, is a severe regulatory and ethical failure. This creates an open gateway for any attacker on the internet to attempt to access the database, directly violating the principle of confidentiality and integrity of data. Such an action would be considered gross negligence and would likely contravene data protection laws that require reasonable security measures to be in place. Another incorrect approach, allowing ingress traffic from all OCI internal subnets to the database port without further restriction, is also professionally unacceptable. While it might seem more secure than allowing all internet traffic, it still lacks the specificity required by the principle of least privilege. If other OCI resources within those subnets are compromised, the database would be directly exposed. This failure to granularly control access demonstrates a lack of due diligence in protecting sensitive data and could lead to regulatory penalties for inadequate security controls. Finally, an incorrect approach that involves disabling NSGs entirely for the database subnet to simplify management is a critical security and ethical lapse. NSGs are a fundamental security control in OCI. Disabling them removes a vital layer of defense, leaving the database exposed to all network traffic. This is a direct contravention of security best practices and would likely violate compliance requirements for data security and availability. The professional reasoning process for similar situations should involve a thorough understanding of the application's communication requirements, identifying all legitimate sources of traffic, and then meticulously configuring NSGs to permit only that traffic on the necessary ports. This should be followed by regular audits and reviews of NSG rules to ensure they remain aligned with current security policies and operational needs. When in doubt, err on the side of caution and implement stricter controls, then iteratively loosen them only after careful validation. Question 18. Which approach would be most effective in ensuring that the introduction of a new Oracle Cloud Infrastructure service, such as Oracle Autonomous Data Warehouse, into an existing enterprise environment is managed responsibly and minimizes potential disruptions to ongoing business operations? Option A. Focus solely on the technical integration requirements and performance benchmarks of the new Oracle Cloud Infrastructure service, assuming that business impact will be minimal. Option B. Conduct a comprehensive impact assessment that identifies all potentially affected systems, data, users, and business processes, and quantifies the potential consequences of the new service's deployment. Option C. Proceed with the deployment of the new Oracle Cloud Infrastructure service immediately, relying on the expertise of the operations team to address any issues that arise post-implementation. Option D. Gather informal feedback from a few key stakeholders about their perceived needs and concerns regarding the new Oracle Cloud Infrastructure service before proceeding with deployment. Correct answer is B. Conduct a comprehensive impact assessment that identifies all potentially affected systems, data, users, and business processes, and quantifies the potential consequences of the new service's deployment. Explanation. This scenario presents a common challenge in cloud architecture, balancing the need for rapid deployment and innovation with the imperative to understand and mitigate potential impacts on existing systems and business operations. The professional challenge lies in proactively identifying and assessing risks before they materialize, which can lead to significant disruptions, financial losses, and reputational damage. A thorough impact assessment is crucial for informed decision-making and ensuring that new cloud initiatives align with organizational objectives and risk tolerance. The correct approach represents best professional practice because it systematically evaluates the potential consequences of introducing a new Oracle Cloud Infrastructure service. This involves identifying affected systems, data, users, and business processes, and then quantifying the potential impact in terms of availability, performance, security, and cost. By performing this assessment early, architects can identify mitigation strategies, adjust the deployment plan, or even recommend against the change if the risks are deemed unacceptable. This aligns with the principles of responsible cloud adoption and risk management, which are implicitly expected in professional IT engagements governed by general IT best practices and the implicit duty of care to the organization. An incorrect approach that focuses solely on technical feasibility without considering broader implications fails to meet professional standards. It overlooks the potential for cascading failures, data corruption, or unauthorized access, which could lead to regulatory noncompliance, e.g., data privacy violations if sensitive data is mishandled and significant business disruption. Another incorrect approach that prioritizes speed over thoroughness, such as deploying without any form of impact analysis, demonstrates a disregard for due diligence. This can result in unforeseen operational issues, increased support costs, and a failure to meet service-level agreements, all of which are professionally detrimental. A third incorrect approach that relies on anecdotal evidence or assumptions rather than structured analysis lacks the rigor required for sound architectural decisions. This can lead to underestimation of risks and inadequate planning, potentially resulting in project failure or significant post-deployment problems. Professionals should adopt a structured decision-making framework that begins with understanding the business context and objectives of any proposed change. This should be followed by a comprehensive impact assessment that considers technical, operational, security, and business implications. Based on the assessment, risks should be identified, evaluated, and mitigated. The final decision to proceed, modify, or defer the change should be based on a clear understanding of the potential benefits versus the identified risks and the organization's risk appetite. Question 19. The control framework reveals that a newly deployed Oracle Cloud infrastructure environment hosts sensitive customer data and must adhere to strict data access and auditability requirements. The architecture team needs to implement a system for managing user access to various OCI resources, including compute instances, object storage buckets, and databases. The primary goal is to ensure that only authorized personnel can access specific resources and that all access activities are logged for compliance purposes, without granting excessive permissions. Option A. Grant all users within the organization the Administrator IAM group, which provides full administrative access to all OCI resources to simplify access management and ensure everyone has the tools they need. Option B. Implement strict network security rules at the VCN level to restrict access to OCI resources, and rely on these network controls as the primary mechanism for managing user access, disabling most IAM policies. Option C. Create custom IAM groups for different roles e.g., developers, administrators, auditors, and assign granular IAM policies to these groups, granting only the necessary permissions for each role to access specific OCI resources. Option D. Disable all IAM policies and rely solely on the default OCI security configurations, assuming they provide sufficient protection for sensitive customer data. The correct answer is C. Create custom IAM groups for different roles e.g., developers, administrators, auditors, and assign granular IAM policies to these groups, granting only the necessary permissions for each role to access specific OCI resources. Explanation. The control framework reveals a common challenge in cloud architecture, balancing the need for rapid deployment and innovation with robust security and compliance requirements. Specifically, this scenario tests the architect's understanding of Oracle Cloud Infrastructures, OCI, Identity and Access Management, IAM, capabilities and their application within a regulated environment. The professional challenge lies in ensuring that access controls are not only technically sound, but also align with the principle of least privilege, a fundamental tenet of security best practices and regulatory compliance. Misinterpreting or misapplying IAM policies can lead to security vulnerabilities, unauthorized data access, and noncompliance with industry standards or governmental regulations, which are critical considerations for an Oracle Cloud Infrastructure 2023 Architect Associate. The correct approach involves leveraging OCI IAM's granular policy capabilities to grant specific permissions to users and groups, ensuring they can only perform actions necessary for their roles. This adheres to the principle of least privilege, which is a cornerstone of secure cloud deployments and is often mandated by regulatory frameworks. By creating custom IAM groups and assigning policies to these groups, the architect ensures that access is managed centrally and can be audited effectively. This proactive and structured approach minimizes the attack surface and reduces the risk of accidental or malicious misuse of cloud resources, representing best professional practice. An incorrect approach of granting broad administrative privileges to all users, even with good intentions for ease of use, represents a significant regulatory and ethical failure. This directly violates the principle of least privilege, increasing the risk of unauthorized access, data breaches, and compliance violations. Such a broad grant of access makes it difficult to track who performs specific actions, hindering auditability and accountability. Another incorrect approach, relying solely on network-level security without robust IAM controls, is also professionally unacceptable. While network security is important, it does not address the internal threat landscape or the need for granular control over resource access within the cloud environment. This oversight can lead to compliance failures if regulations require specific access controls at the resource level. Finally, a strategy of disabling all IAM policies and relying on default OCI security settings is a critical failure. OCI's default settings are often not sufficient for regulated environments and do not provide the necessary granularity or control to meet specific compliance obligations, leaving the environment exposed and non-compliant. Professional decision-making process for similar situations should involve a thorough understanding of the specific regulatory requirements applicable to the data and workloads being hosted on OCI. This includes identifying the types of data, the sensitivity of information, and any industry-specific compliance mandates. The architect must then translate these requirements into concrete IAM policies, always prioritizing the principle of least privilege. Regular review and auditing of IAM policies are essential to ensure they remain effective and aligned with evolving security needs and regulatory landscapes. Collaboration with security and compliance teams is also crucial to validate the implemented controls. Question 20. Stakeholder feedback indicates a critical business unit requires immediate deployment of a new application to meet a time-sensitive market opportunity. They have requested direct access to provision resources within the OCI production tenancy, bypassing the standard security and compliance review process to accelerate deployment. As the OCI architect, what is the most appropriate course of action? Option A. Provide the business unit with a separate, isolated sandbox environment that is not subject to the same security and compliance checks as the production tenancy. Option B. Grant the business unit direct provisioning access to the production tenancy, with the understanding that they will implement security controls themselves to expedite the launch. Option C. Politely decline the request, citing the strict adherence to security protocols, and inform them that they must wait for the standard review process to be completed, regardless of the market opportunity. Option D. Engage with the business unit to understand their application's requirements and guide them in selecting and deploying pre-approved, compliant OCI services within the existing secure framework, ensuring all data handling adheres to organizational policies and U.S. data protection regulations. The correct answer is D. Engage with the business unit to understand their application's requirements and guide them in selecting and deploying pre-approved, compliant OCI services within the existing secure framework, ensuring all data handling adheres to organizational policies and U.S. data protection regulations. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture, where a business unit's immediate need for rapid deployment conflicts with the established security and compliance requirements mandated by the organization. The professional challenge lies in balancing agility with governance, ensuring that the cloud environment remains secure and compliant without unduly hindering innovation or business operations. The architect must navigate potential shadow IT, data residency concerns, and the risk of non-compliance with organizational policies and potentially relevant U.S. regulations, as this is the implied jurisdiction for Oracle Cloud Infrastructure certifications, unless otherwise specified. Correct approach analysis. The correct approach involves engaging with the business unit to understand their requirements and then guiding them through the established, compliant cloud adoption process. This includes leveraging pre-approved OCI services that meet security and compliance standards, utilizing existing secure network configurations, and ensuring data is stored and processed in accordance with organizational policies and U.S. data protection laws. This approach upholds best professional practice by prioritizing security, compliance, and governance, which are fundamental to responsible cloud architecture. It demonstrates a commitment to risk management and ensures that the organization's cloud footprint is secure and auditable. Incorrect approach is analysis, allowing the business unit to bypass standard security reviews and deploy resources directly into a production tenancy without proper vetting poses significant regulatory and ethical risks. This could lead to violations of data privacy regulations, e.g., HIPAA if healthcare data is involved, or general data protection principles under U.S. law. Unauthorized access to sensitive information and potential breaches that could result in financial penalties and reputational damage. It also undermines the organization's security posture and compliance framework, creating a precedent for future noncompliance. Providing the business unit with a sandbox environment that is not properly isolated or secured from the production environment is also a failure. This approach still carries risks of data leakage or unauthorized access, even if not intended for production use. It fails to adequately address the core security and compliance requirements and could inadvertently expose sensitive data. Directly refusing the request without offering alternative, compliance solutions demonstrates a lack of collaboration and problem-solving. While maintaining security is paramount, a rigid refusal can stifle innovation and lead to the business unit seeking unauthorized workarounds, which is a greater security risk. This approach fails to meet the professional obligation to facilitate secure and effective cloud adoption. Professional reasoning. Professionals should adopt a collaborative and risk-aware approach. When faced with such requests, the decision-making process should involve 1. Understanding the business need and its urgency. 2. Assessing the associated risks, security, compliance, operational. 3. Identifying compliant OCI services and configurations that meet the need. 4. Engaging with security and compliance teams to ensure adherence to policies and regulation. 5. Communicating clearly with the business unit about the process, timelines, and available compliance solutions. 6. Documenting all decisions and configurations for auditability.